Okay, this is the Math 1111, 12 p.m. Zoom meeting on September the 10th. And so we intend to work problems from sections 2.1 and 2.2. We're only getting 2 Zoom meetings this week because we were off on Monday with Labor Day. So the first problem a student asked me to work was page 192. Problem 25, this is from 2.1. And the idea is you're given a function, that's the fancy mathematical name, a lot of people call it a formula, and you want to plug numbers in. Plug some numbers in and then plug some other things in. I think it has 6 things it wants you to plug in. And so we're plugging in 2 here first. This is read G of 2. And it means basically the X is a placeholder. Anything, it says basically take 1 minus whatever that is over 1 plus whatever that is. In this case, it is 2. I'm going to put 2 in for this X. 1 minus 2 over 1 plus 2. Come out individually. 1 minus 2, negative 1. 1 plus 2, 3. Negative 1/3. This is the y value, the output of the function. The 2, anything in the parentheses, is the input to the function. And the letter in front right here is the name of the function. A lot of them are named F, but they don't have to be. Next thing they want is negative 1. So we put in 1 minus negative 1 for the X. 1 plus negative 1 for the X. Top will come up 2. Because the 2 negatives turn positive. 1 plus 1 is 2. But on the bottom, we got a problem. 1 plus a negative 1 is 0. Dividing by 0 is illegal. It's an undefined number. And we just write undefined. Not a legal output there. Finally, a half. Same thing, we'll put in a half for the X. 1 minus a half over 1 plus a half. You can almost do it in your head. 1 minus a half would be a half. 1 plus a half would be 1 1/2, which is 3 halves. You can do it with common denominators as well. 1 is 2 over 2. Common denominator is 2, stays the same across. 2 minus 1 is 1. 2 again stays the same across, and 2 plus 1 is 3. Fractions divide out by taking the top, multiplying by the flip of the bottom. So that goes 1/2 times 2 over 3. 2's we cancel because they're on top and bottom, leaving, multiply what's left, you're left with 1's, 1/3. Then it asks for 3 letters for inputs, and these are almost easier. Whatever letter they give you, it's just a matter of putting it in for the X. So the G of A, again, G of X is 1 minus X over 1 plus X. 1 minus A over 1 plus A. And since these are unlike terms, hope you know not to cancel the A's. Don't do that if you want a good grade. It's done. As for G of A minus 1, again, you put A minus 1 where the X is. 1 minus A minus 1. And this is tricky. You got multiple pieces, so a minus sign in front of that is going to distribute. You have to write that in parentheses. Because then you'll go 1 minus A, but plus 1. Bottom, you don't have to write the parentheses of plus 1. They don't usually think of it as distributing. It doesn't change anything. So it doesn't matter if you put them in. 1 plus A minus 1 will leave you A. The 1 minus 1 is a 0. You don't have to write A plus 0. You can just leave it A. Top 1 plus 1 is 2 minus A divided by A. And again, I hope you know not to cancel the A's if you've got a plus or minus sign there. And the very last one, same problem. This is problem 25. I wish they'd put parts to these things. They just kind of put it beside itself. Problem 25, I believe. Yeah. Very similar. Put x squared minus 1 where there's an x. 1 minus an x squared minus 1 over 1 plus an x squared minus 1. Minus sign distributes again. 1 minus x squared, add 1. 1's cancel, leave the x squared. 1 plus 1, 2 minus x squared divided by x squared. All right, another example, next one, problem 35. And they wanted you to compute two things to compare them. I wish they'd set this off in parts, but they don't. F of x plus 2, first thing, that means you stick in x plus 2 where the x is. X plus 2 squared, add 1. You could FOIL out and bring in the 1, and it's not wrong, just a different form of it, expanded form of it, but we're not going to make you do that. You can leave it alone. And then they wanted you to do f of x plus f of 2, just to give you show you the difference. Well, f of x is the original formula. It's off the page. F of x is the original formula, so you're just plugging in the x squared plus 1 for the f of x. 2 plugs in for the x. That gives you 2 squared plus 1. X squared stays alone. 1 plus 4 is 5, plus 1 is 6. Unlike terms, you're done. For an input of x squared plus 1, you get an output of x squared plus 6. All right, we're going on down to problem 61. This is again section 2.1. Talking about the domain of a function. This will be a very important thing we're going to find. It's a set of valid legal x inputs that you can put into a formula or a function. So when you graph, it really works off how you graph off a calculator. It's very similar. When you graph, you have a window. We've done some graphs, so hopefully you know what the window key is. Here's the window key. So the domain are basically these first two buttons. Now that's called the calculator domain. This one happens to be between -3 and 3. A lot of times we use -10, 10, 1. But you can take any domain to be the x min, x max. It's just that if you have a formula with no problems, okay, I'm going to give you first an example with no problems, x minus 1. All right, generally, if they don't tell you anything different, use a calculator domain of -10, 10. I'll put it back to that. 10. On the y equals, I'll put in x minus 1. Okay, so you enter the formula, go to the window. First two keys are your calculator domain. Graph. And you get a nice straight line. Goes through a y-intercept of -1. Remember mx plus b. M would be 1 here, the slope, and this would be the y-intercept. But we do not want you to write down this domain for the answer. The line goes forever in both directions, out to -infinity and to +infinity. So your actual domain answer is literally this, -infinity to +infinity, enclosed -infinity to +infinity, enclosed in parentheses, because your infinity is not a number that can ever be equal to. It just means that the x's are getting infinitely big, and you still have no problems in each direction. In plain English, sometimes you may have seen a capital R for all real numbers. In other words, you can take any number in the world, subtract 1 from it. You have no problems. So what are your problems? There's really two of them. So you must recognize when a formula has problems. And there are two problems. First one's fractions. Stick the same formula on the bottom of a fraction. I hope you recognize you got a problem. If you Or to make x equal 1 here, 1 over 1 minus 1, you'd be dividing by 0. You can set that bottom equals 0, add 1 to both sides. X equals 1 is a problem. You can't use 1. It's not in the domain. So what you've got to do, I've made a picture of the all real number domain. You got the same kind of picture, but you got to put in a 1 here, and you got to stick an open circle. 1 is illegal in this formula, but you can use numbers both sides. So that splits it up into 2 intervals around 1, negative infinity to 1 with parentheses, union with 1 to infinity. Both sides around 1. You just can't use exactly 1 in this. You have a problem, fraction problem in this one. The second problem, problem 2 here, we call them the square root problem. Square roots must be greater than or equal to 0. And it's really even roots as well, because there's a fourth root problem in 67. It's got the same problem. You cannot put negative numbers into square roots. You get an I. You cannot take square roots of negatives. You get an I. It's illegal. So I'll just create the problem, take the original formula with no problems, x minus 1, we'll stick it under a root. So you could stick in x's like negative 3 minus 1 is negative 4. Square root, oop, illegal. So to identify, what x's you can use, what x's you can't, you stick what's under a square root greater than or equal to 0. You have to know how to handle this when you read the form of the formulas. That means x minus 1 is greater than or equal to 0. Add 1 both sides, and the x's have to be greater than or equal to 1. That is its domain. In x, you can graph that. You'd stick a closed circle on 1. And greater than, you're on this side. You see, can you see? You can't, that's what I was trying to say up here. You can't use negative 1 over here, or anything over here. Negative 1 minus 1 is a negative 2. Square root of negative 2 is an I. Can't use it. So the domain and interval notation off of this graph, you'd go 1 comma infinity. With a closed circle, you use a bracket. This is why we did those interval problems in chapter 1. All right, so the first problem a student asked me about was problem 61, and it has a third root. You have no problems with this function. Odd roots are not a problem. Here's why. Just an example. Take a third root of a negative 8. A third root is a number times itself 3 times. That gives what's underneath. In this case, it'd be negative 2. It's not a problem. That's because the signs work out to give you the negative underneath. A cube root of a negative 1 is negative 1. Negative 1 times negative 1 times negative 1 is negative 1. A square root of negative 1 is an I, illegal. And this has no fractions. There's nothing on bottom that you could ever be dividing by 0. No problem with an odd root. This one has no problems. The automatic answer when you have no problems, domain, negative infinity to infinity. You can take any number, subtract 1, take a third root of it. No problems, no illegal numbers. All right, so more examples, something like 69. And this is where things get tricky and how it's technical and how it's hard to tell you every single detail. But I just said square roots make them greater than or equal to 0. Well, that applies if you're on top. But this one's not. So you're going to handle that by taking off the or equal to. So you can't be equal to 0 on the bottom. You'd be dividing by 0 if it were. In other words, if I put in 4, I'd have square root of 4 minus 4 is 3 over the square root of 0, which is 3 over 0. It's illegal. So on the bottom, square root on bottom is strict greater than. You want it positive, but you can't use equal. If you'd used equal, the x would be 4. That's illegal. You'd be dividing by 0. So you want the x's strictly greater than 4. It's an open circle on 4, still positive, because you can put in 5 minus 4 is positive, 6 minus 4. But you can't use 3. You can't even use 4. 4 minus 4 is 0. You'd be dividing by 0. 3 minus 4, you're negative. You can't do a square root of a negative. You can't use anything this side, like 3 or 0. 0 minus 4 is negative 4. So your domain is 4 comma infinity, parentheses on the 4. You can't use 4. That's why it's a parentheses. Yeah, technical details, you really have to remember that. Last one for this section is problem 71. It's got the same issue, fraction with a square root on bottom. There is no problem with the top. No problem. So you want your bottom greater than 0, 2x minus 1 greater than 0, 2x greater than 1, x greater than 1/2. Lay it out on the number line, 1/2, have an open circle, shaded to the right, 1/2 comma infinity, with a parentheses there. Any number between 1/2 and infinity works, but you can't use 1/2. You can almost see it. You'd have 2 times 1/2 minus 1. 1 minus 1 equals 0. All right. Section 2.2. Just give you a few problems to get started. It's a lot shorter. It's about graphing, so you probably already know about it. Very first one, graph y equals negative x plus 3. It says in the directions to do it by making a table of values, but you don't have to do that. Don't you use calculator, not table of values. All right, go back to y equals, and you've got negative x add 3. Go to your window, and the reason I chose this one is that right beside this they gave you this. Well, they are giving you the calculator domain, and they want you to use x min to x max, and they're giving you that, but they're not telling you the y min and y max. You can leave those negative 10 and 10 on y min and y max. Maybe this is confusing. Y min, y max. And the scales can be stayed 1, 2. So I go to window, they're saying to use negative 3, 3, and I'll leave the scale 1. They didn't tell me what y's, so I'll leave those negative 10, 10, and 1. Graph, I get a downward slope line with a y-intercept of 3. Use calculator. Just make your best picture of it. That's really all they want in this section. All right, the very last section jumps kind of to the end, 51 to 55. It's about vertical line test for a function. You may have seen this. First one they ask is 51a, 51b. I drew them both here to contrast it. A function, it can have only one output for any output y for any input x. It really comes from calculators and computers. A calculator or computer can only give you one output for any input. So here is 51a. You pick any input x, and there's only one place to go. At any single x, you can tell there's only one place to go, one y for it at x. This is a function, one y for any x. But you come over here and contrast it, you pick an X, and oops, now you got multiple places, or at least two to go. You could go here, you could go here. This horribly confuses a calculator computer. They're very stupid. It doesn't know whether to give you this one or this one. So we say this is not a function. So yeah, function can have only one output, y, for any input x. Here is the vertical line test, statement of it. If a vertical line intersects a graph only once anywhere, it is a function. So that sort of handles, say, something like a spiral. You can draw a spiral. There are formulas for spirals. You spiral around, and yeah, you come over here, and there's only one y for these x's. It's not good enough. Come into the middle, and you've got multiple y's for these, and that kills it. Not a function. If there's any place you get multiple outputs on a vertical line, multiple intersections, each intersection is an output, it's not a function. If there's any place at all, it can only have, look like this, anywhere along, one output for any input to be a function. That pretty much covers at least the intro to 2.1 and 2.2. We have another Zoom meeting tonight. Since we only got 2 Zoom meetings in this week due to Labor Day, we'll take more questions on these sections next Monday, if people have them, before we charge into the material for next week, next Monday. That'll end the meeting. There will be one more Zoom meeting tonight at 9 p.m. for this week. Thank you.